uh, finalized and it was undergoing under the leadership of Dr. APJ Abdul Kalam. And initially, the world record created by in 2008 is a 10 satellite in various orbit. So single rocket putting satellites in different orbit. So it can operate multiple times. That is another one world record. It's almost 44-meter height and vertically assembled stage by stage. It is assembled under this what is called a mobile MST, what is called mobile service tower. It is almost a multi-story building. So one by stage is assembled, and after fully assembled, this mobile service tower is moved back almost more than 1.5 kilometer, and satellite will be this launch vehicle will be launched. That satellite will be carried at the top portion, which is covered by a heat shield to protect aerodynamic heating at the time of launch. This was the start of the launch, and initially the ground. First stage is started firing, and it is started going. It will go up, and it will remind that the mission will take place depending on the launch vehicle and orbit, almost 30 minutes, around 30 minutes. And once rocket reaches the particular orbit, then the satellite will be injected into the orbit. And apart from PSLV can launch only satellite in the lower orbit. And if you want to have a communication satellite, it has to be launched in a geostationary orbit. And I will tell what is geostationary orbit in the later part of my discussion. GSLV is primarily developed to launch communication satellite, a series of satellite, what is called Indian National Satellite Program, which is under for communication satellite, which will be orbiting above equator, 36,000 kilometers above the equator, and it will have a 24-hour continuous communication, 24/7, which can be used for communication, weather monitoring, navigation, and even for military application, so many other. It has to be put in 30,000 kilometers. So we need a powerful launch vehicle compared to PSLV. So GSLV started developing. It is compared to PSLV. GSLV is the 3-stage rocket, and PSLV having a solid motor and liquid motor, and GSLV is having a solid, liquid, and cryogenic. Cryogenic is a very low temperature, and this technology is very, very complicated. And initially, ISRO doesn't have this technology. So ISRO has initially bought a cryogenic engine from Russia. Almost 6 engines are bought, and meanwhile, ISRO has started developing. Maybe it is after 11 to 12 years it took for ISRO to develop and qualify the cryogenic engine. And later part, Indian indigenous engines have been used. This is GSLV is primarily developed to launch Indian satellite, and it is as I told, it is a solid motor and liquid engine and cryogenic. Use transfer orbit because it cannot directly put 37 kilometers. So it will put in an elliptical orbit called a transfer orbit. From there, whatever propulsion system, whatever engine satellite is carrying, that is used to reach finally circular 36 kilometer orbit. And the 7.5 CE, the cryogenic is 7.5 is a Mark II engine, and Mark III will have a cryogenic engine 20. That is a nomination for the thrust development, and it can put around 4,000 kg. And the GSLV Mark I, 6 number of launches have been taken place, and GSLV Mark II has over 7 launch vehicle have been launched, and Mark III is 4 number of launches have been taken place. And even Mark 3 in the present condition, some additional development, additional improvement is being taken by Isro for manned mission, which is called Gaganyaan, which is under progress. So it need additional some safety measurement, other performance augmentation. So that activity is going on. So this is whatever I told. This is a part of a launch vehicle, whatever developed, and almost we have reached the maturity. We can launch even both PSLV satellite through PSLV for Earth observation, what is called remote sensing satellite for various applications, and also GSLV for launching up to 4,000 kg of satellite to communication purpose and other navigation and weather monitoring, disaster management in a geostationary orbit. So almost we are having our self-reliance with as far as the launch vehicle is concerned, and parallelly launch vehicle development is going on. There are different teams, and mainly the center what is established under the leadership of Professor U.R. Rao, another veteran of space scientist in Bangalore Satellite Center, what is called the Indian Isro Satellite Center, and presently it was named after his memory. It is called U.R. Rao Satellite Center, and he was the first project director for the first Indian satellite, what is called Aryabhatta, which was launched in 19th April 1975 in the orbit of in the elliptical orbit of 611 by 568, and it conducted some of the scientific experiment, what is called astronomy, aeronomics, and solar physics. And it is in the orbit for quite a long time. It is finally it entered atmosphere in February 1992. Once satellites enter atmosphere because of atmospheric heating and track and other thing at a very high speed, it is coming towards the Earth because of the gravitational force, so it get burnt. So after building Aryabhatta was built with the collaboration of Russia, and satellite also launched by Russian launch vehicle, because during that time we didn't have launch vehicle. SLV was developed at the latest stage, PSLV and all. So with the experience gained, about some 300 scientists worked in the Aryabhatta project. So next, after successful launch of satellite Aryabhatta launch and operation for quite a long time, then Bhaskara 1 and Bhaskara 2 additional experimental remote sensing satellites have been launched, and later Indian remote sensing program was established, and where remote sensing satellites have been launched, and these satellites will have up to 4 to 5 years of life. So once life is over for continuous operation, continuous to get a continuous information about our Indian region, so we have to launch the next satellite. Like that, many satellites have been launched, more than 25, 30 satellites have been launched for remote sensing purposes in the name of IRS-1A, IRS, in the name of IRS, then RISAT, and Earth observation satellite like that, Photosat, and so many different names for different applications. And what are the Earth observation satellite application is, it can for agriculture and soil, where it can estimate the crop, how much crop you are going to get for a particular season, depending on whatever is, whether paddy or wheat, whatever is crop is put. For the particular season. So if it is excess, you can procure and store it in for future need. And if it is showing some insufficient because of a drought and rain, insufficient rain and all, you can release the food from the whatever you are having storage stock, so that you can stabilize the market. Otherwise, unnecessarily people will be able to pay a very high cost of because of shortage of production. So, and water set development, horticulture mission, in so these are the applications depending on agriculture and then forest and environment. So biological control also, bio control also it can be used. It can be monitor the forest area and whether anybody is encouraging forest and people are destroying or any forest fire is destroying that. So you can use the satellite image to that and then environmental impact studies because of the forest shrinkage, what is the effect of environmental effect on weather or other rain and that can be studied. And water, potential drinking water. So you can find out where water is available to dig many bore wells and other things. So people use agriculturist farmers, they use some primitive method by keeping some coconut or some stick to find out where water will available in the their land. But satellite can also predict where water is available, and this is more reliable, more than 95%. It will be true. It will be reliable information will be good, and reservoir sedimentation. How much water is because of sedimentation, water storage will become lesser and lesser. That sedimentation has to be cleared. That information can be done. Then land use, we can map the city and land so that you can plan a city development and you can even municipalities and corporations, they can plan their tax collection and other thing. And another is weather monitoring and you can find out ocean, how temperature changes and monsoon forecasting, how cyclone is coming, and ocean. Another is potential fishing zone. That is where more fishes are available. That data also it can be identified by using the remote sensing satellite mapping, and this information will be transferred to fishermen so that they need not go in the sea and waste their fuel and time. They can go particular location and they can catch fish. This information is being given for the last 15 years. And dedicated satellites are what is called Oceansat 1, Oceansat 2 are already there. Another important is disaster management. And for whatever damage happened because of the flood, rain or cyclone, you can estimate and you can plan for your rescue operation. So this is one of the picture, whatever remote sensing satellites taken, and this is the part of Delhi. This is the picture called, this is taken by a satellite called Cartosat 2A. And this is a part of Madurai city taken by Cartosat 2B, that is the next satellite. And because why I am putting is, I am from Madurai, this is my city. That's why I am displaying this. And another, as what I told, is the disaster management. This is one of the typical satellite picture taken by IRS-P6 from a payload called Advanced Wide Field Sensor. Another is linear imaging sensor, what is called RISC-3. And you can see this is a tsunami, whatever happened, everybody may be knowing whatever happened in December 2004, which is unexpectedly happened. Nobody is imagined such a disaster will happen. And a lot of people have died and property damage and happened, and many people have washed away. They were all simply taken by sea. And many people were not aware, even just before 1 minute, many people were playing in the beach. They were not aware of such a tsunami going to come. So big natural disaster. This is a picture showing the typical of Andaman Island. This is a before tsunami, and which is intact. This island is there. This is a picture taken after tsunami. Tsunami actually happened in 25th December on Christmas Day Eve. You can see this island, single island, has because of tsunami, water entered and it has become disconnected, and there is a water entered and become different islands, each single name. And after some time, after later almost 1 month back, slowly is recovering. So from this only we can come to know what type of damage is happened, and we can plan rescue operation, how to rescue the people and property in the damaged area. And this is another picture where cyclone is forming, and it can predict when it is going to cross the land, so that it can evacuate people where some critical area where damage is going to happen, so that we can save people. But you cannot stop the natural calamity. Cyclone you cannot never stop. But you can predict and you can save property and life of people. This is what another service by remote sensing satellite, which are going around the earth in around 500 to 800 kilometer orbit. And that is a low earth orbit, whatever application I told. Another I told GSLV, which is able to put satellite in geo transfer orbit, what is called GTO. And this geostationary orbit is 36,000 kilometer above the Earth, parallel to the equator. Suppose you put a satellite in that orbit, that also takes 24 hours to make one revolution around Earth, and Earth also make one revolution around Earth. So it is stationary compared to Earth. Suppose you are in Earth and one place, and satellite also moving the same speed, you will be seeing 24/7. So I will tell to understand it better. If you are going in a train, parallelly another track also, one more train is going in the same speed. So what will happen? It is stationary. Both are going in the same speed. So you are sitting in your compartment, and you can see the other person sitting on the opposite train in the compartment, and until it's the train, both the trains are in the same speed, you can see him. That is the same idea, only used for this geostationary orbit, which is used for communication. And all satellite, whatever used for even today for communication, TV transmission, weather reporting, all satellites are put in this orbit only. And so India had a first satellite for communication, which is experimental communication. The name of the satellite is Apple, that is a short form of Ariane passenger payload experiment. I was one who involved in that project. It took almost 4 years, and this satellite was launched by a French European Space Agency's launch vehicle called Ariane from French Guyana in June 1981. Only last month only, we had a celebration for 40 years of completion of Apple launch. And we met all our old people, and we had a very pleasant time to meet many of the colleagues after 40 years. And this satellite used for communication experiment like TV program, radio networking, and even villages also some programs have been transmitted using this. And with this satellite, our team has had expertise to build a satellite for communication application, which can be put in a 36 kilometer, and it can be operated for a longer time. So that gives the confidence, and because with all these things, then satellite, another Indian National Satellite Program started to launch a communication satellite for our application. So this shows one of the famous where Apple satellite is put in the bullock cart. So satellite to bullock cart to satellite. And this is one of it is put on for some electrical test for a particular reason, because some conductivity problem was there. We were putting all that. Then that time, big facility, testing facility were not available. So some people have come with an innovative idea of putting on a wooden bullock cart where it can have non-conductivity, and it can be tested for communication payload can be tested. And this shows the satellite. This is a Apple satellite over which another satellite that is a European satellite for meteorological application. And bottom, this is a technological capsule for getting information about the launch vehicle. And these three together, it was launched by Ariane launch vehicle. Uh, this is a different configuration of inside satellite. This is a multi-purpose satellite which is can be used for communication and also for weather monitoring. Meteorological payload also is there. This is purely used for communication satellite. You can see this whatever side panel. This is what we call as a solar panel, where so many small solar cells are bonded, which converts the sun energy to electrical energy for giving electrical energy for operating various system mounted with a satellite for operating. And there are communication satellites are also had different applications like Earth observation satellite. One is called a village resource center. So villages is not having any contact with the big cities. They are not able to see get many of the technological advances what we are enjoying in a big cities, metros like Delhi, Mumbai, Ahmedabad, Chennai, Bangalore, and all. So through satellite we can connect. So there is a receiving station is established, which is called a village resource center, and there are 43 resource center established across the country in large rural areas, and through that we can have watershed, water information about the water available in and around the village, and you can have panchayat planning. We can map it and tell what are the land available, where what purpose it can be used, and drinking water can be provided, and weather report can be given, and education can be given, training can be given to farmers and ladies for vocational training for learning some professional skill. And telemedicine, this is another thing where medical facilities given through satellite for remote area people, where we are enjoying a super specialty hospitals and super specialty consultation with expert doctors where they are not possible. At most, they can come to district center and they can have consultation with the government hospital. So that also maybe they have to walk, or they have to come by a bus or other vehicle traveling by 50-60 kilometers. So that is also a medical facility is brought very close to village people. That I will explain in detail the following slide. And training also I told. And then information, whatever information, even agriculture information and weather information. Like another thing what I told is potential fishing zone for information for fishermen, that can be given through this village resource center, and which is having a connection through satellite which is put in a geostationary orbit, 36,000 kilometer above orbit. And this is a telemedicine network, how it is work. And these are the telemedicine network in big cities, Chennai, Kolkata, Mumbai, and are a big hospital like Apollo, then All India Institute of Medical Sciences, and Nimans Hospital in Bangalore, like famous hospitals they were connected through this network. And this telemedicine network and receiving stations are established in many of the states, and there will even some mobile vans, 8 mobile vans also part of this network. Even it can go to even a very remote area. Mobile vans go and establish a network through the, and patients go to this network center, and they can through satellite they can tell what is their problem. Patient can tell the problem, whether it is a heart problem or a diabetes or some other thing. They can explain to the doctor what is the problem, and who is sitting in Bangalore or Delhi or Chennai, and he can directly talk through video, and he can prescribe and he can advise a patient to what treatment he has to take, whether he has to go for any laboratory test or like X-ray or scan, other thing. So it can be one-to-one correspondence, and this network is established for then 10, 15 years, around 245 hospitals and 205 rural hospitals and 40 super specialty hospitals in various big cities have been connected with this, and this is continuously operating. And almost more than 3 lakhs patients have been treated so far. This is through satellite. This is through communication satellite. Another application of satellite is navigation. Navigation is getting information about reaching some place. So earlier, what people have, if you want to go in a new place, you will go and ask then and there. You travel 1 kilometer, 2 kilometers, and ask where you have to go, and then local people will give, and there will be a direction. Will be also put which direction you have to go. Suppose you can see on the highway and other thing, direction will be put some city, how much distance from 60 kilometers from this place, which direction you have to go. That part of this now. This navigation, apart from common man application, it is required for military and other applications also. So you all know what is a GPS. We are all experiencing GPS every day. Even our mobile have GPS. So if you want to go, if I come to Delhi, if I want to reach Vidya Mandir classes office, I need not ask anybody. If I put in a GPS, my GPS will guide and I can come by taking any vehicle, or I can drive my vehicle, or even if I hire a vehicle, that will also use the GPS. So it has become common now. Without GPS now it is difficult. And apart from this local application, GPS is having a military application also. Suppose you are, border area, Himalayan hills, remote area, is somebody coming and occupying those areas, how do you come to know? It is through satellite. You can get a picture, and you can how to reach. What is the route? You can reach very fast, and all those things. And you all know Kargil war. Recently, even I think 10 days back, some victory anniversary was also conducted. Maybe 10th or 11th anniversary. Kargil war, during that time, GPS GPS is a American satellite. Is a group of satellites which is giving an international service for and it is having a two different frequency band, and which is the L band is used only for defense purpose. It is not available for everybody. Where it is having a better accuracy than what we are using S band. So during Kargil war time, they have switched off GPS and is blocked. It was not available to Indian area. So our military and other services people had a very tough time to reaching the place. So that time Indian government has decided we let us have our own satellite to have our own navigation. We not depend on anybody else. So that time it is a project what is called the Indian Regional Navigation Satellite System. What is in the short form is IRNSS was formed, and it was having a 7 satellite in total. This system, navigation system, 3 satellite in geostationary orbit, that is 36 kilometer orbit, and another 4 geosynchronous orbit in different location. What is the difference between geostationary and geosynchronous is that geostationary is orbit is parallel to equator. There is no inclination with respect to the equator. Geosynchronous is that is also having 24 hours time for making one orbit, and it is not this orbit is having some inclination with respect to the orbit, so that your line of contact communication will be better compared to geostationary orbit. And this navigation system already established and almost 7 satellite and plus 1 spare satellite also in operation, and it is actually the accuracy is better than GPS. And only thing is now people are working to have a better receiving equipment to put in our chip, to put in our mobile phone, so that even you and I can also use it. It will take some time already, but other our services people are using it. And this is a region. What is the region? What is the center region in which that satellite can give information? Not only India, our nearby countries also can use. And this is a one of the remote sensing. This regional navigation satellite. One of the satellite. Like this, almost 8 satellites have been launched. One satellite life is over, so another 7 satellites required for minimum for having a network, and another 8 satellite is a spare for in case any satellite have some problem, this spare satellite can be used. And another is astronomical. This is a satellite apart from remote sensing and communication, navigation and weather monitoring. It can use it for astronomical purpose also to study different planets in the space. Normally, the planetarium is a powerful telescope and radar are there to study the space. But when you are putting a satellite, and satellite carries some of the telescope, some equipment, and from there you can get a better vision and better information about the different planets and different activities like solar flare and solar storm and gamma burst, gamma ray burst, so many other activities, and also you will have closer information about the space. And this satellite is launched almost 6-7 years back. It is giving a lot of information for our Indian astronomers, and actually Indian Institute of Astronomy is using this data. And apart from another scientific mission is Chandrayaan-1. Everybody, this is a successful launch happened. And not only India with the Chandrayaan-1, not only carry our own equipment, it has accommodated equipment from different countries like Sweden and Bulgaria, Germany, UK, USA, ESA, and Japan, the JPL and NASA. JPL is USA, Jet Propulsion Lab, and so many countries also use. We are given platform for using our Chandrayaan-1 satellite, and it is carried more number of things. And the major mission is to find out whether water is available in the moon. So from our, we had one moon impact probe, which when satellite goes around the moon, this impact probe is ejected from the satellite and it is go and hit the moon surface, and the whatever sensor mounted on this moon impact probe study the soil, and it gives the information the water is available in the form of ice. That was there, and it was also confirmed by another equipment, what is called mini SAR synthetic aperture radar. It is a slightly better equipment, have better accuracy. So later it took at least some more time to get the data from water is available underneath in the form of ice. That is the first. So this is a slide which is having a solar panel, and this is an antenna for communication and other things. This is a fuel tank, all those things. In November 2013, and it took almost 10 months to move the satellite to near Mars, and and in September 2014 it was inserted in the Mars orbit. Then afterwards it started moving around the Mars. Mars orbiter. Why it is called great for our country and it is a world record. These are some reasons why it is called great achievement and world record. Captured Mars orbit in the first attempt. So that's what I told. The first attempt itself it is very successful because many of the other countries they are not able to insert successfully because of failure because you have to reduce the velocity at that particular point so that the satellite because of gravitational force of Mars it go around it in the circular in the orbit, elliptical orbit. Suppose you miss at that point or your velocity is not sufficient, two things will happen. One, it may go, velocity is less, it will go and crash on the Mars. So it will damage the satellite, the mission is lost, it is failure. If it is the velocity is more and you are not able to exactly inject at the correct point, then it will escape the Mars and it will start moving further. It will go in a further away. So that is also further. Once it leave that Mars orbit, then you may not be able to have any contact or you cannot able to command with whatever equipment you are mounted in the satellite. So this two type of failures can happen. It has happened for USSR and USA, and even China is not able to launch Mars. And this is what happened. So, and as I told, Isro also launched. This is a combination of so many countries, but it's how some partial failure, some failure has happened in their equipment. It's not completely 100% successful. And as I told, it was being done in 18 months record time, where NASA also has launched one satellite around that time. It was launched later than our satellite, but it entered the Mars atmosphere 2-3 days in advance. MAVEN, what is called MAVEN, and that took 5 years for completion of the project. And their instruments, their purpose of study is different, and and what we have done is with whatever technology available, we have not developed any new technology or new thing. Whatever technology available, there has been further some development has been done by additional test has been done. With that, this mission, Mars mission was launched and it was successful. And another thesis, almost it was done in the 1/10 of budget used by NASA. This is another record. See, they have used $671 million, and our budget was 73 million. So this is another achievement by Indian space program. And this shows the satellite view where it is called getting assembled in inside a special area, what is called a clean room, where environment is kept very clean and temperature control and dust control. And even people who want to enter, they have to wear clean cloth and they have to cover their head with a mask, cap. And even number of people enter also restricted. They cannot simply, each and everybody cannot enter, only authorized people can enter. And this satellite is mounted in some operation is going on. This is the antenna for communicating the data from Mars to Indian ground station. And another is Chandrayaan 2. After Chandrayaan 1, Chandrayaan 2 project was taken and slightly take some time for because of other priorities have been done. So it was launched in 22nd July 2019 from Sriharikota by using our PSLV. Then orbit insertion was done in 28th August 2019, and orbit insertion also was done very successfully. And Vikram landing It was separated from the orbiter on September 2019, and this attempt was failed. Everybody knows it was everybody was every Indian was expecting and praying for successful landing of Vikram, but unfortunately that has not happened. So it is really a big loss for ISRO. But orbiter is going around. This lower part is called orbiter. This is a solar panel and other thing. This orbiter is going around moon and giving intended information about moon, and it is going on. And this is the latter part which is not able to land smoothly, so it is crash landed, and so we are not able to release a rover inside whatever is mounted in that. So it is not successful. So now people are after failure of this, and with the encouragement of PM, whatever given at that time, with even he discussed with the scientists who were present in the control center, and he has have a lot of appreciation and encouragement. So Chandrayaan 3 project is going on, where only lander will be there, orbiter already, because it is there. Lander will be put launched by launch vehicle PSLV, and it will be taken to moon orbit, and they will try to do some smooth landing. Because whatever failure happened, they have learned so many things. So a lot of other design modifications are being implemented. So Chandrayaan 3 next time, whenever whatever happened, so definitely it will be a successful hope. Let us pray for 100% success of Chandrayaan 3 for a successful landing on the moon. And so there are, this is a past and whatever happened so far in, by ISRO. So there are for continuation of these services, we have future projects of different nature. These are remote sensing satellite under which ResourceSat, CartoSat, RSat, OceanSat, different ReoSat is, they are able to get some natural resources available in our Earth that can be there. CartoSat for mapping and taking mapping of our land, city, and RSat is for communication, this is for military service, where you can get a picture of our area or any enemy movement or any other movement, it can be detected. And because of radar imaging, it can be used for even night, day and night, even with a cloudy weather and the fog. Already some RSat 1 is there, RSat 2 is 2 also there is now next for replacement it is there. OceanSat, I already told, for getting information about fishing, availability of fish in the ocean, like that. And another thing is NISHAR. This is a cooperation between NASA and ISRO. This is another remote sensing satellite, where some part of antenna is done by NASA, and another part of antenna and satellite and will be built by ISRO, and the launch also will be done by ISRO. This is the memorandum of understanding, and this already from our side instrument is already ready. ISRO team has gone presently in NASA doing some experiment testing and all. And communication satellite also, like Indian National Satellite Program and GSAT program, lot of new projects are going on. GSAT 9, GSAT 11 for providing better Wi-Fi connection, communication, and weather monitoring and imaging, continuous imaging of our Indian region. Satellites are planned. GISAT, which is a geoimagery satellite, is another one which is put in a geostationary orbit, so that we will get information continuously. Remote sensing satellite, whenever it comes over our region only, it can take picture and it can transmit. But if we are putting in geostationary, we have visibility 24/7. And one satellite is already ready for launch, and launch vehicle is getting ready.
Yeah, sorry.
Present date is August 12th, they are planning to launch. And
Yeah, Mr. Ramachandran.
ah,
Yeah, sorry to interrupt. I mean, due to the paucity of time, can we just rush through with the remaining
okay.
slides
Almost,
because we have, yeah.
almost it is coming to the end.
Yeah.
So like that, advanced med satellite, and so Chandrayaan 3 I had told, then another further study of Mars, and study of sun, corona, and galaxies, and another important is manned mission. There is another one. This is a artist view of Aditya, study of this is another a big project. This is a manned mission. This is a launch vehicle configuration. This is the orbital, this one, where three astronauts will be sitting inside. And these are the technology required for manned mission. This is almost all this technology has been developed, and almost Isro is ready for next Gaganyaan launch. And this is a crew model where people will be, astronaut will be sitting inside, and they are doing, maybe conducting some scientific studies. And this is a mission profile where launch vehicle take place, and further after all these things, within 16 minutes it will reach the lower orbit. And this model is separate from the fourth stage, final stage, and solar array deployment for power generation of the module. And the module will be going around this orbit for 5 or 7 days. Once it has to come, decided to come back to Earth, de-boosting, that is a velocity reduction will be done, and the crew module will get separated from the service module, and then it started coming towards because of the Earth gravitational force, this aerodynamic braking, and two parachute will deploy from the module, and further velocity reduction and smooth landing of the module in the sea, Arabian Sea, it will be there. Once it is splashdown is there, so people will be waiting with a helicopter and ship and other thing. They will go and rescue the astronaut. Another is one robot also designed to put in the Gaganyaan mission, what is called Vion Mitra. That is a space friend, and where it was displayed 2 years back in Bangalore. Some people are taking it. This is half humanoid, only top port can hands and other thing, and move, and it can speak more than some 8 languages. It can conduct some experiment, and it can give some information about space environment reaction with respect to the human body. This is planned, and it can give companion to the astronaut also. And this is another for Venus, study of Venus. It may be planned in 2024. And another is small satellite launch vehicle, apart from PSLV, GSLV is called GSLV with a 3-stage rocket with a full solid motor. Advantage is it can be assembled within 1 week time, because if PSLV, GSLV take a lot of time, and people, 300, 400 people have to involve for assembly, and it need a dedicated control center and a ground station, launch pad and all. With this, it can assemble within 1 week, and even by using the laptop, you can launch. And it is a cost also 1/4 of the cost of PSLV. It can launch 500 kg up to 500 kilometer. This one. This already is in progress. Maybe this year launch will happen, and already two contract the foreign satellite launch contract already has been signed by Isro for this one, and to have a dedicated launch pad in the Tamil Nadu southern part, which place is called Kulasekarapatinam. So another launch pad is being established. It is work is undergoing. Maybe it will be ready within some time. Meanwhile, if SRSLV is ready, it will be launched from Sriharikota. And another is a space station. Everybody knows the International Space Station, where people are going and astronauts are going and staying there for months together and doing all those things. So ISRO also want to have their own space station. That's what recently his chairman, Dr. Sivan, has made a statement. The plan is there, but it will be take more time after the Gaganyaan project. It will take another 5 to 7 years to have our own space station where Indian astronauts will go and do a lot of experiments. And presently, for this year, PSLV C51 is launched exclusively for Brazil satellite and already done in February. And because of COVID, lot of lockdown and other problem, they have planned more than 12 to 15 launches this year. Because of COVID problem, many of the projects have been delayed. Now, as I told this week, 12th, they are going to launch GA-SAT and 3 more Earth observation satellites by PSLV and SSLV one more launch. And Gaganyaan, what was planned in December 2021, without any astronaut, uncrewed, without any crew, it is also delayed further. And I don't know, ISRO has to announce this one. This is a GA-SAT which is ready for launch. This is a satellite, and these are the heat shield where this is a top portion of the launch vehicle where it is put on overhead and it is launched. It have
hello. Sorry to interrupt. Sorry to interrupt. We have only 10 minutes remaining with us. So there are so many students waiting for some questions also.
Okay, my presentation is over. Now it is open to the viewers.
So thank you so much, Dr. Ramayana. It was a real pleasure listening to you and studying various aspects of the space science, especially about ISRO, So, I mean, for the benefit, the students can pen down their questions in the chat box, So in the meantime, I would like to summarize some of the points which Mr. Arunachalam has shared. So I would share it in Hindi for the benefit of our Hindi viewers. तो जैसा कि आपने देखा कि हमारा जो इसरो जो संस्था है उसकी बहुत ही एक मॉडर्न शुरुआत थी, पैसे का अभाव था, संसाधनों का अभाव था, बट अर्ली 60s में हमारे वैज्ञानिकों की ये दक्षता थी या उनकी कर्मठता थी जिसके आगे सरकार को भी एग्री करना पड़ा। और जो महत्वपूर्ण वैज्ञानिक जिन्होंने मेन रोल निभाया इसको एस्टेब्लिश करने में, जैसे कि आप नाम सुनते हैं विक्रम साराभाई जी का, सतीश धवन जी का, या फिर हमारे अब्दुल कलाम जी का, इनकी लगातार जो मेहनत रही है वो बहुत महत्वपूर्ण रोल प्ले किया है उसने हमारे इसरो को आज इस लेवल तक लाने में। चाहे वो आर्यभट्ट का लॉन्च हो 1975 में, या फिर PSLV की बात करें या GSLV की बात करें, जैसे कि अरुणाचलम जी ने हमें बताया कि विभिन्न प्रकार के लॉन्च व्हीकल्स के बारे में बताया, विभिन्न प्रकार के सैटेलाइट्स के बारे में बताया और क्या क्या एप्लीकेशंस हैं सैटेलाइट्स की, चाहे वो वाटर मैनेजमेंट की बात करें, चाहे क्लाइमेट मैनेजमेंट की बात करें, चाहे सिक्योरिटी या डिफेंस की बात कर रहे हैं, है ना, सभी क्षेत्रों में सैटेलाइट्स का महत्वपूर्ण योगदान है। और 2000 के बाद, सन 2000 के बाद बहुत ही तेजी से प्रगति हुई है इस क्षेत्र में। हमारे साइंटिस्टों ने बहुत तेजी से विकास किया है, हालांकि लिमिटेड संसाधन थे, लिमिटेड पैसा था, फिर भी बहुत तेजी से विकास किया है। क्रायोजेनिक इंजन की बात करें, चाहे से बहुत सारे 100 से ऊपर रॉकेट्स जो सैटेलाइट्स लॉन्च किए अंतरिक्ष में, वो भी एक विश्व रिकॉर्ड था। सो इसरो कीर्तिमान के बाद कीर्तिमान स्थापित करता जा रहा है। और अभी हाल फिलहाल में हमने जैसे मंगलयान की बात करें या चंद्रयान की बात करें, बहुत ही इंपॉर्टेंट मिशन रहे हैं और भविष्य में भी बहुत सारे मिशन आने वाले हैं, चाहे चंद्रयान की बात करें, चाहे वीनस के लिए मिशन की बात करें। सो बहुत सारा इस क्षेत्र में होने वाला है। तो as a student of space science, I mean, there are a lot of opportunities to learn and grow. As well as a citizen of India, we also feel a lot of proud, when we talk about ISRO, because ISRO has given a lot of name and fame to the Indians. So this is what I have to say about the PPT that Arunachalam ji has shared with us. So I think the students are ready with some of the questions. Abhilasha, you may take this forward.
Yes, there are quite a lot of questions. We are extremely overwhelmed. However, I'll ask the ones most asked. So, Sir Vanshika wants to know that what is the scope of aerospace in future?
What is it?
What is the scope of aerospace in future?
Actually, there's a lot of scope is there for aerospace because now if you see overall international scenario and space, this year so far 850 satellites have been launched by different countries within 6 months of time, and a lot of private companies are coming out. You may see now recently the space tourism, part of space tourism, two people have gone to space and come back, and a lot of application. And if you talk about the Indian scenario, now because of common policy, earlier ISRO was the only people who are involved in space research, and they only have the facility. They have only can launch and operate the satellite. And today, because of Indian government policy, it is now open, and ISRO is open, and there are many startup companies have been come up, and they are recruiting people, and they have signed with the MOU with ISRO for development of launch vehicle, development of launching satellite for different applications. They want to launch the constellation of satellites. So definitely there is a lot of scope.
Thank
There's
you, sir.
everything
So
going to
Ayush wants to know that how can he get into ISRO?
ISRO. It is if you want to become a scientist or engineer, you have to join with a engineering degree or physics or mathematics and a postgraduate degree. So after this +2, one way of getting into ISRO is available. What is anybody heard of IIST, Indian Institute of Space Technology, which is only one unique institute available in India, which is a deemed university under Department of Space, which is located in Trivandrum. It takes almost around 120 people in aerospace and avionics. And this is admission is after +2 through JEE advanced course. So if you want to join that, he can refer that website IAST.
Also,
We'll take up one
yeah.
last question as we are running out of time. Muskan wants to know, where does India stand in technology?
India, if you take a large vehicle, satellite technology, we are on par with many other countries. So when we talked about remote sensing satellite, we had a better resolution images compared to even NASA and ESA satellite. They were actually there are many they're buying remote sensing data from our country. Suppose if you take a launch vehicle, our capacity has to still have to improve. Where people are working to maybe because other countries have even 10,000 kg of satellite launching capability. And if you take manned mission, we are lagging compared to US and even China. Because our priority is totally different. China, it is a military rule, and they can do whatever they want. They can allow to fund everything. Here, our democratic country, even when in 1963, it was a Tumba station was launched. There was Vikram Sarabhai always used to face a question from the press. Why a poor Indian country has to spend a lot of money for that? That can be spent in for digging borewell in many of the villages and providing safe drinking water.
Thank you so much. Thanks, sir. Thanks a lot. So, sir, in fact, I mean, for the students who are interested in joining this aerospace engineering, I mean, there are multiple universities which offer this BTech program in aerospace engineering, so they can do the course from there. Also, there are programs in VTech avionics also, which is also a way to get into ISRO. So these are the two programs which are quite useful if you want to join ISRO or any organization which is deals with the
No,
space.
that is a simple, because once you get admission based on your merit, this is all India level competition. You
Absolutely.
get there after completion, successful completion, or better. There is a condition. You have to get a grade point more than 7.5. Then, depending on your vacancy, you have been observed in ISRO.
Absolutely.
So,
So that
almost 90% of the students so far is there. Otherwise, people they can go for higher studies or private, that is possible. Otherwise, what you have to do is any engineering. Suppose if you take which engineering college is better, I'll tell IITs, IISc, NIT. Then colleges are different, state different ranking systems are there. So you can have any engineering course. It need not be aerospace engineering only, because I am an aerospace engineer, and we have a limited number of aerospace engineers in our sector. Electronics engineers are there, chemical engineers are there, control engineer, computers. So many different, all branches are required. It is not
absolutely.
aerospace engineer only can make. Today everything is computerized, software, the controls. So the software engineer is very much required. Control engineer is required.
Absolutely.
Even mathematicians to write the software. Yeah, I told the accurate insertion of Mars mission is very, very important. It is totally depending on software. How
Right,
time
right.
calculate everything. So once you complete a degree, only thing is you have to note everything, everywhere it is all India competition. You have to
Absolutely.
do very well, and you have to come with the flying colors in your performance.
Thank you.
Then
Thank you so much, sir. Thank you so much for your valuable inputs.
ISRO recruitment also, open recruitment is also there, and once in 6 months they advertise through website. You can apply, and if you suit all the condition, if you satisfy all the condition, you will have to write a written exam. Then once selected written exam, then you have to group discussion and into oral, all those things. Once you selected, you will be put in a different work centers, and they will be given a training also.
Right, sir. So thank you, sir. So it was a real pleasure, understanding various aspects of the India's space program with you. I think this will motivate a lot of students to join this field of aerospace, in the future. And definitely, this platform has given us a lot of understanding about a brief overview of India's space program. So thank you so much for taking out your valuable time from your busy schedule and sharing with us some of the major information about India's space program. So, students, I mean, it may not be possible for us to take all the questions because of the positive time, but you can drop your questions in the Dropbox. We will definitely get back to you now.
I saw one question. Somebody asked whether I can become an astronomer. One person has asked astronaut.
Yeah, you may please respond to it.
See, at present, Gaganyaan 4 astronauts have been selected. They are all Indian Air Force pilot. Out of 30, after going through initial screening, 4 people have been selected and sent for training to Russia. After completing the training, now presently they are in India. They are going to take further training specific to their Gaganyaan mission. See, in NASA also they recruit. So normally India, it may take more time for recruiting astronauts from common public or scientists, graduates and other things.
Right,
So basically you require science or technology or engineering or mathematics degree with a good health, and maybe your reflex and all has to be good, and the eye vision, there is some specification, even your dental hygienic also there, physical there you have to undergo centrifugal test for acceleration, deceleration, then temperature, so many other things.
Thank you.
And technically suitable, he may be have a chance to become astronaut.
Right, sir. Thank you so much. So before we conclude, I would also like to share with you that we have a webinar coming up in the month of September, which is almost 1 month from now. So although the topic and the day of the webinar has not been finalized, but you can register yourself for this webinar. I think the link for the webinar has already been shared in the chat box. So you can register yourself through this link. I mean, it is the same link through which you had registered yourself for this webinar. So you can use the same link for the upcoming webinar also. So all in all, thank you so much to everybody, to all the participants, to all the panelists, all the speakers, and especially Mr. Arunachalam for sharing some of the valuable insights about India's space program. It was really a knowledge imparting, very interesting and very exciting session. Thank you so much. Have a great evening, and we look forward to see you very soon in the upcoming webinar. Thanks a lot.
Okay, thank you all.